Hello everybody, today we'll be explaining how to use cramer's rule in solving two variable equations. I'm your friend Abdullah Jalili and let's get going. Well, first of all, what is cramer's rule? Cramer's rule is an explicit formula for the solution of a system of linear equations with as many equations as unknown, valid whenever the system has a unique solution. So that means it can work for two variables or three or even more. Cramer, by the way, is a mathematician called Gabriel Cramer. He was a Swiss mathematician born in Geneva and the year 1700. Right now, we will be focusing on two variable equations, but we will state some differences between a two variable and three variable. In a 2 by 2 or a two variable equation, we need two of those three matrices. We would need the coefficient matrix and the constant matrix. As you can see, we can take those from the two equations themselves at the right. Using the pre-mentioned matrices from before, we can solve for x and y. First of all, we find the determinant of a being the coefficient matrix. After that, we find a1, which is the same as the coefficient matrix but with the first column replaced by the constants. After that, we find the determinant of a1 divided by the determinant of a equals x, which in this case is 2.8. Solving y is almost the same as solving x, where we are going to use the coefficient matrix again to get the determinant of a. After that, we'll find a2, not a1. The coefficient matrix will be replaced by the constants in the second column. After that, we find the determinant of a2 and divide it by the determinant of a, which gives us y, and in this case, 1.7. You should be thinking right now, what's the difference between the two variable and the three variable question? Well, there are about three differences. The first difference is that it contains a third variable which we consider z and becomes a3 afterwards, and it uses a 3 by 3 matrix instead of a 2 by 2, and it has a third constant that is replaced in the third column in a3. And don't forget, the determinant of a must not equal to 0 if you want a solid answer by this. And now I'll introduce you to an Arab mathematician by the name Al-Kindi. He was also known as the philosopher of the Arabs in the 9th century. Some of Al-Kindi's accomplishments include being a polymath, which means he has multiple expertise in different fields, which includes chemistry, psychology, and even medicine. He also developed Islamic philosophies from Greek society and values. He also found proof on the solar system structure based on Greek science. He also wrote 4 books on the use of Indian numbers. And now I'll tell you something special. What if I told you that 1 equals 0.99 repetitive? The algebraic proof. First of all, let x equal 0.9 repetitive. After that, let's multiply both sides by 10, subtract both sides by 1x, which means 9x equals 9. After that, let's divide both sides by 9, therefore x equals 1. And in the end, 1 equals 0.99 repetitive. Thank you for your attentive listening, and I hope I blew your mind. Have a nice day.
Created using Powtoon.